This video is going to go over Lesson 8 from Unit 5, Solving Linear Systems of Equations 3 by 3. To start out today's lesson, I'd like you to try the warm-up question. So take a moment to pause the video, read through the do now, and give it a try. Okay, for this question, we're given two different equations. The equations represent the amount of money collected from this school concert tickets. They tell us that X represents the cost of each adult ticket. Let me just use the same color here. Okay, so X represents the cost of each adult ticket, and Y represents the cost for each student ticket. And we're being asked to find the cost of each adult ticket and the cost of each child ticket. So we're going to end up needing to find both X and Y. So when solving a 2 by 2 equation, way back to Algebra 1, we had two methods that we used. One we called elimination, the other substitution. When we have the equations set up like this, where our X values are lined up, our Y's are lined up, our equal signs, and our constants, this is where you're set up to using the elimination method. So for this method, what our goal is to eliminate one of our variables so that we can solve for the remaining variable. And the way that we do that is we try to add straight down between our two equations vertically so that we can eliminate one variable through that addition, which means we need one of the variables to have opposite coefficients. So I can see here that my 2y terms, I have a term here and a term here that are very close to canceling out. I just need to multiply one of the equations by -1. So I'm going to start like that. I'm going to start by multiplying my second equation by -1, and then I'm going to line these up vertically again. And now what I'll be able to do is when I add straight down, I will be able to eliminate the y variable and only have an equation that contains x. So if I add straight down, 5x minus 3x would be 2x. My 2y and -2y would cancel, and 48 minus 32 will give me 16. So now I'm solving the equation 2x is equal to 16, divide both sides by 2, and I get x is equal to 8. So 8 would be the amount of money for each adult ticket since X represents that amount. Now what we need to do is also go and find the cost of each child ticket, which is what Y represents. So I would need to go back to my original equations, pick one of the two equations to substitute in 8 for X so we can solve for Y. So I'm just going to take that first equation, 5 times 8 plus 2Y is equal to 48. And solve for y here. Subtract 40 from both sides. I get 2y is equal to 8. So y is equal to 4. And again, y represented the cost of our child ticket. Now, this method of elimination is what we will be relying on today, but what we're going to be looking at is a set of equations where we have 3 linear equations as opposed to 2. So reviewing the elimination method is going to help us today. You're just going to see that we're going to use this method more than one time in the problems we look at today. So these types of linear systems serve as a basis for the field of math known as linear algebra. We're going to be looking at 3 by 3 systems of linear equations. And in this first example, I have the equations lettered just to help you kind of keep track, because you're going to see as we go through these questions today that the amount of work It's very important to stay organized in your work because one little mistake can throw off the whole problem, and you're going to see with the amount of calculations we're going to be doing, it will be helpful to stay as organized as possible. So for part A, it tells us that the addition property of equality allows us to add two equations together and produce a third valid equation. So we're going to create a system by adding equations A and B together and then A and C together. So let's start out with the first thing. We're going to add together equations A and B. So here's A, here's B. I'm going to line them up over here. And as I add these two equations together, notice what happens. I have 2x plus 6x gives me an 8x, y minus 3y gives me negative 2y, and look at this, my z terms cancel out. So this is just going to equal 50. Now let's go and add together A and C. Sorry. So we're going to add A with C. So same first equation that we used before, and then C, and when I go to add these two equations together, I get negative 2x plus 5y. Again, the z values cancel. This is equal to 1. Now we're being asked here, why is this strategy effective? Well, look at what we ended up with. Now we have two equations, both in terms of just x and y. So we started out with 3 equations and 3 variables, and by using the elimination method twice, we now ended up with 2 equations with the same 2 variables. So what we're going to do now in part B, I'm just going to move this over so I have room, is we're going to take these 2 new equations and we're going to solve with elimination one additional time. So let's take the 2 equations we were just left with, 8x minus 2y equals 50, and negative 2x plus 5y is equal to 1. And we're going to solve this 2 by 2 system, just like we did in the do now, except for this one, neither one of my variables is set up to be eliminated right away. So we are going to have to multiply one of these equations by something so that either x or y have coefficients that are opposite. So I'm going to take a step and multiply my second equation by 4. By doing this, I should now be able to cancel the x variable. So I'm just going to rewrite my first equation. If I distribute the 4, I would get negative 8x plus 20y is equal to 4. And now looking at these 2 by 2 equations, my 8x and negative 8x will cancel. Adding straight down, negative 2y plus 20y, I'd have 18y equal to 54. Divide by 18. And I get y is equal to 3. So after 3 attempts using elimination, I finally have one variable. Now in part B, it did say we're going to use this 2 by 2 system to solve the 3 by 3. So the reason we would now be able to solve the original 3 by 3 system is because once you get one variable, we can work backwards to start plugging in to get the remaining 2. So since I now know that y is equal to 3, let's just box that in so we don't lose that. We can now work with one of our 2 by 2 equations. So I'm just going to take the first one, that 8x minus 2y. I'm going to plug in 3 for y is equal to 50. So I get 8x minus 6 equals 50. Add over the 6. 8x equals 56. divide by 8, and we get x is equal to 7. So now we have another one of our variables known to us. And it's only now that we have two known variables, y is 3, x is 7, that we can go all the way back to the original 3 by 3 equations and plug these values in to get the third remaining variable, in this case z. So let's take x is 7 and y is 3 and plug in to get z. So I'm going to use this first equation. So 2 times 7 plus 3 plus the unknown variable of z, that's the only thing I don't know at this point, is equal to 15. So 14 plus 3 plus z equals 15, 17. And when I subtract the 17, I get that z is equal to -2. So to solve a 3 by 3 linear system like this, you end up using the elimination method 3 times. So now let's go ahead and try another one. I know there are some calculator steps in your notes. We're going to go through these tomorrow in class, so for right now I'm just going to skip over them, and we're going to solve the next system algebraically as well. So this little note before exercise 2 just says, just as in 2 by 2 systems, sometimes the 3 by 3 systems will need to be manipulated before we can eliminate any variables. So when looking back to our work in number 1, we didn't have to manipulate either, equations A, B, or C. When we were eliminating Z, all we had to do was line up A and B and then A and C. Because we already had these additive inverse terms, there was no manipulation we needed to do. So in number 2, we might need to do a little bit more work. So the first thing you want to do is at least identify what the easiest variable is to eliminate. So take a moment to look at these 3 equations and see if you can determine which one just appears to be the easiest to eliminate. And if you were thinking y, you are correct. Now, this doesn't mean that you could not have eliminated x or z. You can, but because y has a positive 1 and a negative 1 in front, and then one of the equations has a 4, it's going to take the least amount to eliminate that variable, and we'll work that out now. So our goal here is to eliminate y. So just like earlier, why don't let's call these A, B, and C. So what I'm going to do first is I'm going to add together A and C. Because I can see right there, those are already additive inverses. So let's take 4x plus y minus 3z is equal to -6. And 5x minus y minus 7z is equal to -19. And when I go to eliminate y here, I don't have to do anything except add straight down. I get 9x, the y's cancel, minus 10z is equal to -25. So my goal right now is to create another system, another equation that will just have x and z by eliminating y. So I've already used my first and last equation. So in this next attempt to eliminate y, I do have to use equation B, but I can use equation B with either A or C. So I'm going to choose to use equation B with equation C, since C already has a negative y and B has a positive y. But we are going to have to do a little bit of manipulating to equation C in order to get it to eliminate with that 4y. So let's say we're going to line up B. We're going to add B, and we're actually going to add B with 4 times C. So I'm going to write that here. So, B is -2x plus 4y plus 2z is equal to 38. And when I go and line up equation C, The reason I wrote 4 times c is because in order to get this equation to have the y variable cancel, I'm going to need to multiply it by 4 so that that second term becomes a negative 4y. Okay, so let's rewrite the first equation. And then my second equation, as I distribute the 4 times 5x would give me 20x. 4 times negative y is negative 4y. 4 times negative 7 is negative 28z. And it's equal to 4 times negative 19, which is going to give me negative 76. Okay, so now we're ready to add straight down. Okay, so we get 18x. The y terms will cancel. And, sorry, we add over the 2z and the negative 28z to get negative 26z equal to negative 76 plus 38, which is 38. Negative 38. Okay, so we now have 2 equations, both with x and z, by eliminating y. And what we're going to do is we're going to take these 2 equations, 9x minus 10z equals negative 25, and 18x minus 26z equals negative 38, and we're going to set them up now as our third and final attempt with the elimination method. Okay, so looking at this 2 by 2 system, we need to decide what we're going to eliminate. So just take a minute to think about which variable to you appears to be easier to eliminate. If you're thinking x, you're correct. It's going to be a little bit easier because all we're going to need to do here is multiply the top equation. Let's make that top term a negative 18x by multiplying the top equation by negative 2. Okay, so distributing the negative 2, I would get negative 18x plus 20z is equal to positive 50. Again, that's distributing the negative 2 to my entire 3 terms in that equation. Then the second equation, I'm not manipulating, I'm just going to rewrite it. And now I'm ready to add straight down. So my 18x and negative 18x will cancel. I get negative 6z, and this is equal to 50 minus 38, which would give me 12. Divide by negative 6, and we get a z equal to negative 2. Now that I have one of these variables, I can plug this value into one of my 2 variable equations. So one of the 2 that are highlighted in yellow, I'm just going to pick the first one. So 9x minus 10 times z, which is negative 2, is equal to negative 25. So 9x plus 20 equals negative 25. Subtract the 20. So 9x is equal to negative 45. Divide by 9. We get x is equal to negative 5. Okay, so now we have 2 variables. So once you get that second variable, now you're ready to go all the way back to one of your original equations and plug in. So negative 2 is z, negative 5 is x. I'm going to plug into the top equation. So negative 5 is x, and negative 2 is z. and that would all be equal to negative 6. So negative 20 plus y plus 6 is equal to negative 6. Negative 20 and 6 add together to be negative 14. And then if I add over the 14 to the negative 6, I should get a y value of 8. Okay, so when solving a 3 by 3 linear system, you want to first decide what variable you're going to eliminate, and you need to eliminate it twice out of all 3 of your equations. You are always going to end up using one of those 3 equations twice. So in this example, we did use equation C twice. In the first example, we used equation A twice, right? So it's one of your equations is going to be used twice, but you have to make sure you use all 3 of them at least once. As soon as you come up with your 2 variable equation, you do your third and final elimination, which will then result in your first known variable. And when you go to plug in to find your 2 remaining variables, start with the 2 variable system, plug that into one of those 2 equations that you created. And then finally, you have enough information once you have 2 variables to plug into one of your original equations to get the third and final variable. I hope this video was helpful to review algebraically solving 3 by 3 systems. We're going to practice the calculator steps. There is a couple of great ways, 2 main ways to use the calculator. So if this happened to be multiple choice, you wouldn't have to do any of this algebra. And because this algebra can be so involved, it's extremely helpful to be able to check yourself in the calculator after completing a question like this. So we'll look at that tomorrow in class.